Hello dear, welcome back. So as you see, I came from outside and wearing a mask. So please always put a mask whenever you go out. And we are living in a very critical situation, as all of you know, the global pandemic of coronavirus is actually engulfing everybody. Okay. So be safe. Okay. So with this message, now as we as I promised in the last class that I will talk about applications of fuzzy logic. There's a huge application everywhere almost. Okay, but before doing that, I will tell you a small story. Unfortunate, um, you see, in 1960s, right? Lutfi actually he wrote paper, influential paper, and is considered to be father of fuzzy logic. When all these things were happening, many scientists in the and practitioners in the Western world, they thought they some sort of undermined fuzzy logic because perhaps the fuzzy term was there. They maybe misunderstood that it is the logic which is fuzzy, which is not. Fuzzy logic is a logic which can capture the fuzziness of the environment. So that thing was realized by Japanese people and many scientists, Sugeno, and many others. You see, I already discussed his inference system. So they could realize the true potential of fuzzy logic, and a number of products were developed. Everything was going on, and then in the Western world also they realized, and then things took a very dynamic state. So today I am going to discuss, as I promised, that application of fuzzy logic. It has a huge application in industry. For example, automatic transmission, automatic gearbox. You know that you have paid some money and bought a car which has automatic transmission. That's all. You do not know that what is the technology behind it. Only thing is, it is giving you comfort not to put stick and slip gear, right? So behind the scene, fuzzy logic is working actually. So it is analyzing that based on, say, your car is climbing a steep hill, right? So you need to lower the gear, right? So automatically it has to be done. You do not know, but fuzzy logic, together with the actuating and control devices and sensory devices, it is actually doing that. So in automatic transmission, similarly in four-wheel steering, okay. So you have four-wheel drive, especially when it is snowing, right? So that your car will not slip, you need to have control. Four-wheel drive control is there. Then cruise control. Cruise control is another um, modern feature of any automobile, right? So that is there. Say you are riding a car and um, comfortably at 60 miles per hour speed, you press the button cruise control. So it will try to maintain the same speed. And now suppose the car is going a downhill, right? So speed will tend to increase. So there is a sensor, and then fuzzy logic is there. So sensing that, fuzzy expert system will adjust the fuel injection of the car so that less fuel is injected and then speed is reduced. Okay, all kind of then consumer electronic and domestic goods nowadays is a smart television, microwave oven, fuzzy chip is there, refrigerator, fuzzy refrigerator is there, washing machine, fuzzy washing machine is there, fuzzy chip, and I think every household has this kind of thing. Air conditioner. So depending on, or humidifier, depending on the current, if the room temperature is high, then the temperature you are setting, say 20 degree. So accordingly, the compression needs to be pumping out heat from your um, room, and it should run longer rather than when already temperature is near to your uh, desirable temperature. It should not run. So all kind of um, uh, logical um, inferences can be drawn by fuzzy logic. another stock market prediction, weather forecasting. So everywhere almost fuzzy logic nowadays used. Now, having shared all this, you see, I am planning to discuss how to design a fuzzy washing machine using Sugeno approach. Okay, so let us try to, and in designing that, I will use a expert system shell. You know what cell is? Cell is just like empty architecture. It is analogous to, suppose, as we have also discussed in my next lecture, a office, new office, and nothing is there, no furniture, no other equipments and all kind of thing. This is you who will actually furnish the office, right? Empty office is just like cell. Okay, so we have an expert system cell. Many open source expert system cells are available, and I am using, since we have MATLAB in our institute, so we are using expert system cell, fuzzy expert system cell of MATLAB. So in the command prompt, if you just type fuzzy, then you will get expert system cell, and I will try to use that for designing a fuzzy expert system for running the washing machine. So for actually designing any inference system, fuzzy inference system, like any other system designing, you will have to understand the problem. Then here you need to identify the inputs and outputs. Then here you need to fuzzify with appropriate membership function. Then you need to write rules, because very carefully, because here only you are capturing the actual knowledge. If you write bad rules, performance will be poor. If you write very efficiently rules, then performance of your inference system will be very, very accurate. Then you aggregate the when the rules are fired, as we have talked in my earlier lecture, we aggregate the outputs, and then you defuzzify to get the result, right? So we are doing the case study using Sugeno method. We'll design a fuzzy washing machine, fuzzy chip, which will be installed in a fuzzy washing machine, so that in a very optimal way it will consume less resources and give you maximum output in terms of removing the dirt and the grease or stickiness or oiliness from your dresses. So for that, let us identify two inputs. So this is in your hand. Now you are in the designer seat. So you are the boss, right? The way you will select the parameters, the way you will select, write the rules, the way you will get the result, okay, good or bad. And let us also see that gives the output is actually two inputs are dart, level of dart of the cloth or dress, and the grease, right? Whether oily substance are there or not. So these are the two things which I decide my fuzzy expert system should process to give me the optimum output. What is the optimum output? The fuzzy controller actually must tell me washing time. Okay, how much washing time I should have optimally. Okay, so I will just now try to. You see, as I told you that I will. This is my expert system cell. So by default, Mamdani approach is coming. So I told that I will use Sugeno approach. So I have now a Sugeno type of expert system. So fuzzy expert system I am designing. You see, now I will have to um, add variables, right? Input. So how many inputs? Two inputs, right? I have decided I will use two input. So input 1. So say it is level of dart, and then say okay. So these are my, so you see the cell has given you input output in general way, and now I can just configure it to solve my problem. And then output, no, one output, right? So I'll be satisfied with one output. Now what we'll have to do, we'll have to add a membership function, right? You see, this is the level of dart. See, membership function by default it is there. Say I will tell this membership function I am demarcating for say low dart, less or less dart, okay, and say I have by default so many membership function. I am selecting this, so I am selecting, right, average less dart, okay, and say my membership Gaussian like that, okay, and say less average high, high level of dart, okay, and say okay. So this is my one input. Another input similarly I'll have to do dot grid less, say low low, and then I have say decided del separate, okay, average. You see, I am just selecting average, low, all kind of fuzzy thing, but actual result which I will get is not fuzzy. Low grease, average grease level, and then you see average, okay, and then this is say high. Okay, so now output I will have to three membership functions are there. So this is I am calling membership function 1. So what will be my output? Washing time, right? So high or low was it? Average washing time, and sorry, low. Low washing time, then average, okay, washing time, okay. So in this way, input, output variables I have decided, membership functions so I have added. Now I'll have to add the rules, write the rules, okay. This is the most important one, right? Now, you see, here you are capturing expert's wisdom. If the level of the dart is less and the level of the grease is low, then washing time should be low. You agree? I agree. So I add this, okay, as a rule. When it will be fired, you will get some spike, length of some spike. So if the level of the dart is less and this is average, and then grease is average time, say I decide. If the level of dart is less and high, then high washing time, I decide. Okay. So similarly, if it is average, dart is average, and then grease is low, again I consider this average, and the grease is average, then I consider this is justified. Average dot, high grease, and then you see, I think that it should be, that means my motor will run longer. Okay. So if then dot is high, low grease, okay, still average, okay, average, still average, and then high grease, dart is high level, grease is high level, definitely high washing time should be there. Okay. That's it. I have captured expert's opinion in the form of if then arising if then rule. You see, if the level of the dart is this and this is this, so and operation is there, as you know, now spike. So I need to now view the rules which I have written. See, I have written these rules. So now level of dart is this 0.5, level of 0.5, output, crisp output you are getting 0.494. Well, that's it. So I have got the output. Now, most tedious thing which I will also explain in my next lecture is to test what you have done is correct or not. If not, then you see, you will have to do the experiment, right? A lot of. So you see that dart is 2, this is 2, and then output is 3, means although they are low value, output means the machine will be running longer, so it may not be correct. So what to do? You can you can come back, maybe some of the rules you have written wrongly. Okay, so you'll have to check again. So this is expert's opinion. I wrote something whimsically, right? But if an expert is there, engineer is there, so who is dealing with, okay, manual machine, washing machine, this much dirt takes this much time. If she or he knows, then she or he will be an expert, and I need to consult to make my design more perfect. So this is called feedback, right? Getting feedback, and this is a loop. Design is a loop, right? So again, you redesign by either changing the rules or changing the what you see. You have taken this kind of membership function. There are so many other membership function, so you can change the membership function also. But output you cannot change the membership function. They are the singleton membership function in case of Sugeno method, right? So in this way, I can you can also visualize the surface, okay? See, which will tell you more beautifully that okay, if the level of grease is low and level of dirt is low, and then you are getting output that is you need not run machine for longer time. At least visually you are seeing that design is actually um, good, okay, isn't it? This is 0. So as your dart level is increasing and uh, grease level is increasing, dart level is increasing, then of course you are getting higher time. So basically, design is more or less correct, but you need to fine tune, and lot of laborious thing you need to do. You need to just spend several hour time in consulting the expert and getting your past data to fine tune all these things. That what would be the most suitable membership function, what will be the rules I should incorporate. So if you do them correct, after several iteration, you fix the design. Now, once the design is fixed, you got the data, right? So this data actually in the form of if-then rule you have written, in the form of lookup table, those data will be stored in a fuzzy chip. So that chip which you see is inside your machine, because in the machine this kind of laborious thing, computationally expensive thing cannot be done. So these are all happening in the design stage. Once design is there, you'll have to customize. It will go to the manufacturing. Okay. Similar, right? If you design a software, lots of codes you write, but few codes are going to the production, right? So you make the design, freeze the design, put the if-then rule in the form of a lookup table. All this you will have to do beforehand, and then burn a chip. No more changes, okay? And then the machine will actually take those values. It will sense the dart level and reduce level, and accordingly it will fix that what time, how long the beater, the motor will run. So in short, I think this is an interesting one. I wanted to show you that using Sugeno approach, inference approach, how can you design a real system, expert system, which can control household devices like um, washing machine. Huh? You can take any example, and I will continue. I will do the similar kind of thing in my next lecture. That will be my concluding lecture, last lecture. I will take a Sugeno approach, which is more common, and will demonstrate solving some problem, uh, how to design a system to solve real life problem. Okay. Till then, stay safe and wear the mask wherever you go. Stay safe. Take care. Bye bye.